everyone, welcome to our channel. Today we'll solve one word question related to draft tube theory. The word question is related to the calculation of depth of the straight draft tube. So let's start the question. A question is given as a Francis turbine works under a head of 25 meter and produce 11760 kilowatt while running at 120 rpm. The turbine has been installed at a station where atmospheric pressure is 10 meter of water and vapor pressure is 0.2 meter of water. Calculate the maximum height of the straight draft tube for a turbine. We have to calculate the height of the straight draft tube. Now let's move towards the solution. First of all, we have the given data is power is 11,760 kilowatt, which is converting into megawatt is set to 11.76 megawatt, and netted is given as 25 meter. Turbine running speed equals 120 rpm and atmospheric pressure HA equals 10 meter, and the vapor pressure HB equals 0.2 meter. Now let's start the solution. We know the specific speed Ns equals n root over P is divided by h power 5 by 4, where P shall be considered in kilowatt. Substituting the value of N, P and H, that is turbine running speed, head and power in the specific speed formula as this. On solving this, we will get the result as Ns equals 232.79 rpm. After this, for the setting of the turbine, sigma C is equal to 0.625 times of Ns by 380.78 whole square. On placing the value of Ns above calculated value of Ns, that is specific speed, on this equation and calculating it, the result will be 0.233 meter. After this, the setting of turbine equals subtraction of atmospheric pressure, vapor pressure and multiplication of setting of turbine with netted, and placing all this value on the formula of the setting of turbine as this, will get the result of 3.96 meter, where the maximum depth of the straight draft tube is 3.960 meter, which is the final result. So for today we end up for this much. We will come again with one new video. Till then, keep on watching our channel and don't forget to subscribe us. Thank you.